our next speaker is going to be Dayna Baumeister. Dayna has been involved with something called biomimicry. How do you design with nature in a way that things become more productive? How do we look at nature and design things? Dayna has been involved in this movement since 1998 with her partner, Janine Binyas. She now has something called Biomimicry 3.8, where they train, certify, and connect biomimicry professionals worldwide. Is there anyone in Canada who's been through her training? I'm just curious, anybody here? Yay, that's great. But she's really got a terrific program. She's helped more than 100 companies consult the natural world for elegant and sustainable design solutions, so you can see sort of the connection between what Dayna talks about and the cradle to cradle and the circular economy. Given this experience, Dayna will be exploring what she believes is an important design guidelines to follow to achieve zero waste, circular economy, and all kinds of innovation that we can all learn for. Please welcome Dayna Baumeister.
So it's always an interesting adventure to travel across the country and to look out the airplane as a biologist and see the very striking difference between that which we as a species are responsible for and that which the other 30 million or so species on this planet are responsible for. And it's very, very visible even from 30,000 feet up. And part of the work that I do is to try to change that so that we don't stand out as such an oddity on this planet, and instead we learn to fit in. Because of course, as we all know, this is a finite planet. It is a place that we call home, but it is not our home alone. In fact, the 30 million species that live here today represent less than 1% of all the species that have ever lived on this planet. And we are just one of those species, and we are not at all immune to the laws of natural selection. So we need to ask ourselves, what does it mean to be a species here on this planet, and how might we do things a little bit differently? Is this really the kind of legacy that we want to leave behind? We won't just be fossil bones in the geological timeline, but we've left quite a few artifacts in our wake. And of course, a lot of that comes from the industrial revolutional approach to being on this planet. We make things, we use them, we dispose them. And a lot of the work in the zero waste space is around trying to change that equation, as we saw some of the diagrams go up before, and it says, well, let's close that loop, and that will solve the problem. Well, as a biologist, I have to ask myself, is that really all that it takes for zero waste? Is it really just taking the end of that one pipeline and connecting it back to the beginning and we're all good? And I have to say that when I look back over 3.8 billion years of research, and I look at what all of the other organisms are doing, that's actually not the answer. That's not the design principle. And I want to talk a little bit about that here today. When we look out at these ecosystems that surround us, no matter where you are in Vancouver or in the world, we all can go for a walk in the woods or in the prairie or swim in the ocean and go, well, this is a great example of zero waste. It's not here. There's no landfill here. So what is it that makes that work? What is it that allows us to look at the natural world and say clearly, there's no waste here? That is what we are trying to achieve. Well, they've had a little bit of time advantage ahead of us. The other species collectively have 3.8 billion years of R&D. But what we have to our advantage is we have these big brains. And so we can start to use our ability to mimic others and mimic those other species in order to learn. So what might we learn? Well, this is exactly what the more or less exactly what the diagram looks like in the natural world. It is not a loop at all. It is rather a cascade, and it is a network, and it is an internet of things, as we've just learned about. This is a diagram of a food web, which is really the production, make, use, and dispose web of the natural world from a coral reef. And you can see there's no loops about it. So forget all that stuff you learned in your biology textbook. You know, it's not that the lion eats the deer and the deer makes an insect and the insect feeds the grass and the grass feeds the lion again, you know, or the bug. You know, that's not the way it works. It is a web, and that's what allows the natural world to function in a space of zero waste. But there's a couple of design principles that I want to share with you today. And at the core of this is asking ourselves that, well, what happens when we blend and bring the world of biology and nature and life together with design and innovation and technologies? For so long, we've thought of those as separate things. Nature's over there, we're over here. But we are nature, and we ultimately have to find the intersection of those two if we want to live past the next century, if we're lucky, as a species. And in that center is what we consider biomimicry. And by using biomimicry thinking, we can begin to bring those lessons to the table. So that conscious emulation of nature's genius does say, well, you know, after 3.8 billion years, maybe you do have something that you could offer us. And we can look to nature as a model, and using design from the natural world. We can look to nature as a measure and actually get real metrics of what does zero mean? What is the appropriate thing for this place? What can we learn from these ecosystems? And we can look as nature as mentor. So how does nature actually achieve zero waste? Let's ask that question and see what she might say. Well, one, of course, is don't generate it in the first place, all right? But that's not the only way or the only strategy. The second strategy is, well, don't create it during the use of whatever it is that you're using. And then the third strategy is don't actually call it waste, of course, is what we know of waste equals food. And nature puts all three of these together. So let's look at them in a little bit more detail. This button doesn't like me. So make just what you need. When this lily grows this flower, there's no cut-off waste, as Jeremy talked about. It is exactly what that plant needs to attract the pollinator to achieve the success of its seeds and its offspring. Keep what you have. A caterpillar transforms every single cell into its body using Imaginell cells, which is such a cool name, to create the butterfly. There's no waste at the end, and in fact, many insects, when they metamorphize, will now eat that cocoon and turn it all, use exactly what they have and use it over. And then, of course, turning waste into resource. I read a statistic once that said if dung beetles were eliminated from India, that within 3 months, India would be covered in 3 inches of human feces alone. And so dung beetles, of course, are the classic epitome of turning waste into resource, but all of life uses these other wastes as resources. There's no such word as even waste. So make just what you need. In order to do that, you have to build from the bottom up. This era of additive manufacturing, 3D manufacturing, is just one of the important technologies that allows you to do that. Building from the bottom up is critical. You have to integrate growth with development, which means not invest everything in development and not have any growth to feed it, but not put everything into growth and not have any development to support it. And those two pieces are critically important and allow you to make just what you need. And then life uses multifunctional design. We tend to make one thing and produce one function from that. So stromatolites are a great example of bacteria builds from the bottom up, one cell at a time, and creates entire reef infrastructures. Bird bones, a great example of integrating growth and development, only putting material where you actually need material, and therefore you don't have any extra. Beetles are a great example of multifunctional design. Those exoskeletons don't just contain the innards, they reflect color, they attract mate, they maintain moisture, they provide structural integrity, all using just a single material. What about using what you have? Well, you need to keep it so it works and lasts as long as it should. So life embodies and builds in resilience for the inevitable disturbances and breaks and cracks and things that will go wrong. Life maintains integrity through self-renewal. It actually self-heals. And there's new materials that are coming out that allow for self-healing. And life fits form to function. So whether we look at barnacles for examples of embodying resilience, able to withstand all sorts of temperature and moisture changes, impacts from waves, incredibly structurally enduring materials that last just as long as they need to last. Or we look at rhino horn, which is not a living material, but is capable of self-healing. When there's a crack from impact with another rhino, it can heal. And what can we learn from those lessons? And fitting form to function, those dandelion seeds only need to be carried a far enough distance away from the mother plant, and there's no extra material involved in there at all. And then in the disposal category, believe it or not, life actually doesn't really care about what it disposes of. It doesn't plan for someone else to use its waste. A tree doesn't go, well, I'm going to design my leaves so somebody else can make use of them. But we can. However, there is an emergent property in all of life's waste that allows it to be a resource, and this is something that we can design for. So one, if you use readily available materials and you use it to make your stuff, and therefore when your stuff breaks down, it's the same readily available materials that everybody else is interested in. You need to use life-friendly chemistry so that you're not producing any toxins in your materials that nobody else wants and can't make any use of. You need to make sure that your products can break down into benign constituents. So yes, you might be a rattlesnake and you may be producing toxins, but when those toxins break down, they're completely benign and can be made use of by others. You need to use low-energy processes. Just the laws of thermodynamics teach us the amount of energy that goes into producing an object is the same amount of energy to break down that object. So we shouldn't be so hard or so surprised that it's so hard to break down that which we produce and let others make use of it because we put so much energy into creating it in the first place. And then, of course, leveraging the cooperative relationships so that you can actually have that flow of materials. So whether or not you're a sea urchin and you're using calcium, carbon, and oxygen, calcium carbonate in order to create your entire shell, really, really common, very abundant elements on the planet, and can be used when they break down by many, many other organisms. Life creates fabulous, amazing colors without the use of heavy metals. Most of the pigments and the things that we create today have heavy metals and toxins in them. So how could our chemistry be transformed? How could we break down our products and look at how other organisms break down those pieces so that they can be building blocks for other organisms? Mushrooms are notoriously good at doing that. This is the inside of an abalone shell, the strongest ceramic on the planet today, but it's made at room temperature. So scientists are learning about those lessons of how those shells are sandwiched together. And of course, leveraging cooperative relationships abound from examples in the natural world. These are leafcutter ants. They're involved in a 5-kingdom relationship between plants and fungi and bacteria and the animal world with the ants in order to manage and keep that network, that web, that flow of nutrients going. So what might it look like if we began to cooperate? If we began to ask the natural world for advice? How can we make, use, and dispose of things differently? Maybe it's the eco-industrial parks that are starting to build those webs and close those loops together. Maybe it happens at the product level where we learn lessons from spiral trees in order to create water bottles that contain 15% less raw material because of the shape alone achieved with that spiral. Maybe we use algorithms and software to help us generate actual shapes and materials that do exactly the function that we need to achieve. Or we look to nature and we learn how nature gathers carbon and turns it into sugars, which become raw materials for building blocks, such as New Light Technologies has done in creating plastics from CO2. Or we better learn how to preserve our goods so that they don't break down, and looking at the vast majority of vaccines end up in the landfill because the preservatives aren't done well. So what can we learn from tardigrades and the water bear? Maybe we need to learn about attachment and detachment devices so that we can better unlock and take our parts apart so that they can become valuable resources for others, like this inspired by the blue mussels. And maybe we can completely rethink how we make things today. A big thing that ends up in landfills and in our oceans are fishing nets. Well, these folks in Spain looked at humpback whales, and humpback whales don't use nets to catch fish. They use bubbles, and bubbles have no waste. So these guys have laid down tubes on the bottom of the ocean floor and create bubble nets to catch fish. And biomimicry allows us to ask those big, fundamentally different questions and completely transform the way we do things. Even interface carpet and their whole ecosystem of the flow of goods, not just in what's on the floor, where the materials come from, where they go. It's not just carpet into carpet, it's car parts into carpet, it's carpet into fishing nets and fishing nets into carpet, and being involved in that huge web. Because it's this web is the only way that we'll ever achieve zero waste. That web of what's happening here on this coral reef allows us to create conditions conducive to life. And that's ultimately what our mission should be as a species. Humans creating conditions conducive to life. Vancouver, my company, my organization, my city, my municipality is something for us to strive for. Thank you.